The invention of X-rays represents one of the most significant breakthroughs in the history of science and medicine, marking a profound shift in the way humans could perceive and understand the internal structure of the physical world. The story begins in the late 19th century, a period characterized by rapid scientific exploration and discovery in physics, chemistry, and medicine, during which the understanding of electricity, magnetism, and radiation was expanding dramatically. The central figure in the invention of X-rays is Wilhelm Conrad Röntgen, a German physicist born in 1845 who had spent years studying the properties of cathode rays, which are streams of electrons observed in vacuum tubes when an electric current is applied. By experimenting with these cathode rays in various glass tubes, Röntgen observed unusual fluorescent effects when certain materials were placed near the tubes while they were operating, leading him to hypothesize the existence of a new type of penetrating radiation. On November 8, 1895, Röntgen made his groundbreaking observation while experimenting in his laboratory at the University of Würzburg. He noticed that a fluorescent screen coated with barium platinocyanide began to glow even though it was positioned several feet away from the cathode ray tube and shielded by heavy cardboard. He realized that the rays emanating from the tube were able to pass through opaque materials and project the silhouette of solid objects onto the screen, a phenomenon that had never been observed before. Intrigued by this unexpected behavior, Röntgen meticulously documented his experiments, testing the ray's ability to penetrate different substances, from metals to human tissue, and observing how bones, metal objects, and other dense structures appeared distinctly on the fluorescent screen. To illustrate the effects of these mysterious rays, he famously made the first X-ray image of his wife's hand, which revealed the bones and her wedding ring with astonishing clarity, producing a visual that captured the public imagination and demonstrated immediately the profound medical potential of the discovery. Röntgen, careful to proceed methodically, named these rays X-rays to indicate their unknown nature, using the mathematical symbol X for the unknown, reflecting his cautious scientific approach to a phenomenon that was entirely new and not yet understood in terms of existing theories of physics. The discovery quickly drew attention in the scientific community, spreading across Europe and North America as other researchers replicated his experiments and confirmed the ray's unique ability to penetrate soft tissues while being absorbed by denser materials, thereby creating images that revealed internal structures without invasive procedures. This ability to visualize the internal anatomy of living organisms represented a revolutionary advance in medicine, as it allowed for accurate diagnoses of fractures, foreign objects, and a range of internal conditions, transforming clinical practice and surgical planning almost immediately. Moreover, the invention of X-rays catalyzed further research into the nature of electromagnetic radiation and the structure of the atom, influencing contemporaries such as Marie and Pierre Curie, who would go on to discover radioactivity, and paving the way for the development of modern diagnostic imaging technologies, including computed tomography and fluoroscopy. The initial reception of X-rays was marked by excitement and curiosity, as both the scientific community and the general public marveled at the ability to peer inside the human body without surgery. Yet it also came with a period of experimentation during which safety hazards were not fully understood. Early practitioners were unaware of the potential harm of prolonged exposure to X-rays, leading to instances of burns and radiation injuries, which later informed the development of protective measures and standards for safe medical use. Röntgen's discovery was so impactful that it earned him the first Nobel Prize in Physics in 1901, a recognition that cemented his place in scientific history and highlighted the transformative nature of his work, not only for physics, but for medicine and technology at large. The rapid adoption of X-ray technology in hospitals, military field operations, and scientific laboratories worldwide underscored its versatility and practical significance, as it enabled physicians to perform more precise surgical interventions, helped researchers study the properties of materials, and even influenced art and archaeology by allowing the examination of paintings and artifacts without causing damage. The fundamental principle behind X-rays, the ability of high-energy electromagnetic waves to penetrate materials to varying degrees based on density, remains the cornerstone of modern radiography and medical imaging, illustrating how a single discovery can open a vast spectrum of applications that continue to evolve over time. Röntgen's meticulous experimental approach, his careful documentation, and his decision to share his findings openly with the scientific community exemplify the ethos of scientific inquiry that leads to rapid dissemination and application of knowledge, demonstrating how curiosity-driven research can have far-reaching consequences beyond the original scope of investigation. In summary, the invention of X-rays by Wilhelm Conrad Röntgen in 1895 was a landmark achievement that combined rigorous scientific observation, innovative experimentation, and a profound understanding of emerging physical principles, resulting in a technology that fundamentally changed medicine, physics, and our perception of the hidden structures of the world. By revealing what had previously been invisible and enabling non-invasive exploration of internal anatomy, X-rays not only revolutionized diagnostic medicine, but also stimulated further research into the nature of electromagnetic radiation and the structure of the atom, influencing contemporaries such as Marie and Pierre Curie, who would go on to discover radioactivity, and paving the way for the development of modern diagnostic imaging technologies, including computed tomography and fluoroscopy. Beyond its immediate medical applications, the discovery of X-rays also influenced societal perceptions of science itself, demonstrating how experimental curiosity and meticulous observation could produce tangible benefits for humanity, fostering public interest in scientific investigation, encouraging education in physics and medical sciences, and contributing to the broader cultural appreciation for empirical knowledge. The sense of wonder generated by the first X-ray images, which allowed people to literally see through matter, highlighted the potential for scientific tools to extend human senses, bridging the gap between theoretical physics and everyday practical use. Moreover, the rapid integration of X-ray technology into medical curricula, research laboratories, and industrial applications underscored a new era in which science was directly linked to problem-solving and innovation, ultimately shaping the trajectory of the 20th century in both medicine and technology. Röntgen's legacy persists not only in the equipment and techniques that bear his influence, but also in the mindset of scientific exploration he exemplified. A relentless curiosity combined with careful observation, systematic experimentation, and an openness to the unforeseen consequences of discovery, showing how a single insight can transform multiple fields and touch countless lives in ways that extend far beyond its initial conception, thus making the invention of X-rays a cornerstone in the story of human understanding of the natural world and a timeless example of the power of human ingenuity.